Alright, so today we're going to go, day 154, we're going to be modeling exponential growth and decay. So modeling, I'm not talking about like a model, duck face.
You're recording this.
Did you say duck face?
Duck face.
Duck face model. I'm talking about modeling stories, okay? So math is about, I know math is boring sometimes because you just do plain math, but life is about stories. We can apply math to it and understand problems and figure out, make better decisions from it, okay? And today we're going to talk about that. One of the things we use is exponential growth and decay models in life. So because that always happens, especially like money. Money is all about exponential growth or decay. Or like one day you might want to buy a house. Usually it's exponential growth, okay? Very rarely is it exponential decay. We'll talk about that today. So, or when you buy stuff, like a textbook in college, you're going to buy the textbook. And do you think that textbook is going to be this, when you sell it, do you think it's going to be the same price as when you bought it? No, right? So when you understand these things, you kind of build a sense of urgency on how to make better decisions. Okay? So we're going to talk about these two models, exponential growth and decay. And I'm just going to get going here, because we started off a little later in the period, okay? So here we go. Annual sales for a company are $155,000 and increases at a rate of 8% per year for 9 years. Okay. Who's a business person here? Does someone sell stuff in here? Is there a hobby? Does someone have a hobby? Anyone have a hobby? Okay, let's just say I'm going to pick on Emily. Okay, so Emily's a musician, okay? And let's just say she has a company that is, she runs her music through because she's like getting popular, and she sells her music when she goes to venues. She has like T-shirts and bracelets and stuff that have her artist name on it. Okay, so every year she makes $155,000. It's pretty good, right? High school student, right? So in this example, her annual sales are $155,000, and they increase at a rate of 8% per year for 9 years. Okay, so let's think about this in terms of math. Okay, so let's think about percentages. Let's take us back to 7th grade. If you had $155,000 this year, and let's say you keep $155,000 for next year, how many percent of the $155,000 did you keep for that second year?
100.
How many percent, everyone?
100.
100%. Did y'all understand that? Or, for example, another way to think about it, you have a whole pizza right now. You don't eat it today. How many percent of the pizza do you have for tomorrow?
100%.
100%. Does that make sense? Okay, good. Okay, in this example, Emily's company has $155,000 she made this year. And what does it say? It increases at a rate of 8%. So that means, is she earning 100% for next year, or 100 and what percent for next year? 108%. Do you all agree with that? Okay, cool. So just by seeing this, I see that we know that she's going to actually have 108% next year. And I can write that as a decimal by moving the decimal point 2 places to the left, okay? So we got 1.08, okay? And we can make an exponential model by this information, okay? So we're going to start with our step 2. It says y equals A. So A is going to be our initial amount she's making per year, which is $155,000. Okay. The second thing we have is our rate, or our B. So what's the B for this company? It's going to be 1.08. Okay. And that's going to be to the T power, which is how much time goes by. Here's our model. We just modeled her profit, or her growth in profit for the next few years. Okay. So now we could go to graph this on Decimos. So let's all pull up Decimos, please. To the power of t. And in this case, we don't want to use t, we'll use x, because usually there's an x up here, right? Okay. And then I don't see a graph here. Why don't I see a graph, everyone? We have to zoom out, right? And what does X represent? What did X represent, by the way? Time, right? The number of years. So how much time were we talking about in the problem? Well, we were talking about like from 0 to 10 years. So we're going to change our zoom for our x-axis to go from 0 to 10. Okay? And then the y-axis will go from 0 to like, let's just go up to like 300,000. Because that's how much money she's making, okay? So here's her graph. What does this kind of look like? Exponential growth or decay? Exponential growth, right? It's saying how much money will she make in 9 years. So I could figure out any year. Let's say in 1 year, how much money will she start making? So x equals to 1. Look at that. Remember what I taught you yesterday or 2 days ago? It's where the lines cross. In 1 year, she'll be making 167,400. What about pick another number between 1 and 10, someone.
5.
Okay, 5 and then 9. In 5 years, she'll be making, where the lines cross, oh, that's 4.9 years. In 5 years, she'll be making 227,745 and 85 cents. And then 9 years, she'll be making, let me zoom out a little bit more, $309,845. So do you see how a percent increase, it helps the percentage of the income increase? Y'all see that? Does this make sense, everyone? Okay, cool. All right. So let's go back to the lesson now. All right, so that's for number 1, and it says how much will she have after that time. We just figured out it was like about 302,000 we looked up. Okay? Does this all make sense? Okay, number 2. Number 2, the value of a textbook is $69 and decreases at a rate of 15% per year for 11 years. Any college-going people here? Who's going to go to college? Okay, so we got a few people. Okay, let me call on someone else. Olivia. Okay, Olivia's going to go to college, okay? Olivia's going to go to college. For her first day there, one of her teachers is like, hey, it's her math teacher. You just go buy a textbook. It's the math book. It's $69. Can you go buy it? Okay, she goes and buys it, okay? So, do you think when she keeps her book after she's done with it, will it be the same price? Will it be more in price or less in price? Less in price, okay? Does that make sense? So, let's think about conceptually again. Let's say she buys the book for $69 and then after a year, she could sell for $69. How many percent of the money does she get back?
All of them, 100%.
100%, good. But in this case, how much percent does the book decrease in the first year?
15.
15, right? So what's 100 minus 15?
75.
85.
85, good. So we're going to look at this 15 and we know that she'll actually have, or her book will be 100 minus 15, which is 85%. How do we write that as a decimal?
0.85.
0.85, that's right. So we got y equals 69 times 0.85 to the x, okay? Or to the t, in this case, because we're talking about time, okay? Does that make sense so far?
Yeah.
Okay, now we're going to go to the Decimos. Okay, so let's go back to Decimos. And when we do this one, when we look at Decimos, it's good to clear out everything and start fresh. And we're going to put this in. We said it was going to be y equals 69. That's our a is 69, the initial value, times 0.85 is the decimal or the b to the x power. Okay? And then again, why can't I see my graph here? Why? Why can't I see the graph on here? We have to zoom out, right? So I'm going to zoom out here. I'm going to go from 0 to 10 here for the years, and then let's look at the y-axis. I know she paid $69, and I know it's going to decrease, so I'll go up to $70 here, okay? So here we go. What do you notice about my graph? It starts at $69. What do you notice about the value of her book over the years? It's going down, right? So what's after 1 year, we could figure out, we know x is like our time or our t, so x is equal to 1. What's the value of her book after 1 year? Good, y'all see that $58.65, right? What about after 2 years? What's the value after 2 years? Let's see if you can. What was that? Yeah, almost $50. It's $49.85. What about, let's say Olivia waits all 4 years. She's done with college and then she needs to start selling her books because she has to move back home. How much is the value of her books after 4 years? 36. So I got a question for you. Would it be a good idea for Olivia to wait to sell her books, or would it be a good idea for her to sell them as soon as she can? Okay, does that make sense? What kind of model is this? Exponential growth or decay? Good. Okay? Is this hard? So-so? A little bit? Some of you, it looks like it's easier than others. Okay, cool. So that's how you model with exponential equations, okay? Okay, so looking at this next one, let's go to, I'm going to jump over to, number 4, okay? So this one we're going to have you do, number 4. So, here we go. A house is losing value at a rate of 4.5%, 5.4% per year. In 2009, the house was worth $131,000. Find the worth of the house in 2019. Okay? So, all right, so on this example now, everyone, we're back to the house. I'll read it one more time. Our house is losing value at a rate of 5.4% per year. In 2009, the house was worth $131,000, and in 2019, or we want to find the value in 2019. Okay, so working with your group, I'll give you 2 minutes to figure out the equation, and then graph it and find the answer. Okay, with your groups. Ready, set, and go. What's the model on this one? Y equals what?
Y equals 131 parentheses 5
Parentheses what? Okay.
5.4.
No, is it 5.4?
No.
No. So again, think about it this way: how much value of the house do you have if it doesn't increase or decrease? How many percent do you get to keep? 100. Okay. How much is it decreasing though? What did it say?
5.4.
So what's 100 minus 5.4?
96.6.
No.
94.6.
94.6, right? Right? So what is our equation then, everyone?
Y equals 131,000 times 0.946.
Good. Do you all agree with him? Nice. Okay, good. That is correct. Okay. So that's the model. And after, how many years pass by? 10, right? Okay, and that's in 2019. That's how much it's worth. And here is the graph, okay, on Decimos, right? Isn't that what you had? It is a cheap house.
I'm gonna buy it.
Yeah, it is.
You should buy it. It'd be a good investment. Okay?
We don't know that.
What if
Why
it's
is
like
it so cheap?
falling apart?
Yeah, that's why it's so cheap.
Then you fix it and make it worth more.
But then that's
But
like
it
buying a
doesn't-
normal house. Why not buy a normal house and save the time?
Because you can make more profit off this one.
It's called flipping. It's a thing people do.
Yeah, flipping. There you go.
You
Watch.
get house flipping.
So this is a great conversation, okay?
My neighbors are